talking about coding agents a fair bit now, and I think one of the next steps, as soon as autonomy kind of kicks in and we realize, actually, we don't need to nurse or babysit agents quite as constantly as we would an assistant in that more chat format. We can kind of fire and forget a little bit and then wait till we see responses. We think about fleets of coding agents, the ability to actually orchestrate a number of coding agents, and there are a number of reasons why we might do that. One really strong way of being able to do something like this is OpenHands, and we're really, really proud to have the founder and CEO of OpenHands, Robert Brennan, here to talk us through it. So please welcome on stage, Robert Brennan.
Thanks so much. All right, thank you all for having me today. I'm really excited to be here. So today we're going to talk about how to not just run like a single coding agent on your workstation, but to manage a whole fleet of agents potentially running in the cloud. A little bit about me. My name is Robert Brennan. I'm the CEO and co-founder at OpenHands. I've been working in developer tooling for over a decade now, mainly around open source, and have been working in natural language processing for even longer than that. It's been really fun for me to see over the last few years those two worlds really collide as large language models have gotten exceptionally good at writing code. I think it's pretty easy to assume now software development is changing. I think we've all seen our jobs change quite a bit over the last couple of years. I know my day-to-day workflow is radically different than it was 2 years ago. Now I would say literally every line of code that I write goes through OpenHands. I never open an IDE anymore. It's a very, very different way of working, very fun way of working. But one thing I want to convince you of is that we're still in the first innings of this change. The technology itself is getting better and better over time. Agents are able to take on more and more of the work involved in software engineering, and especially more and more of the toil. But it's also, I would say, even if the technology were frozen today, there are still, there's a lot that's possible with the technology that we haven't really cracked yet, both from like a cultural standpoint and an organizational standpoint. And so what I want to show to you today is what we're seeing the most effective, most elite agentic engineering teams doing with agents at scale. A little bit about how we got here. So I would say in the early days of LLMs, you could get them to write little snippets of code, completely unaware of what's going on in your code base, but you could say, hey, write me bubble sort, do it in this programming language, and they were pretty good at writing code. This was helpful. It was kind of a neat supplement to Stack Overflow. And then pretty soon after that, we got what I call like context-aware code generation. So things like GitHub Copilot, where it's plugged into your IDE, and it can see a bit of context about where you're editing, what you're working on, and generate code that's relevant to your code base. So you can see the little robot gets eyes all of a sudden. I would say over the last 18 months or so, we've seen agents come about. Really over the last year, with the invention of tool calling and Sonnet 3.5. And this basically got agents to not just write code, but they could run the code that they wrote, Google an error message that comes out, do that entire inner loop of development. And what we're seeing emerge now is basically using parallel agents in tandem with each other to do larger scale work than a single agent could take on. A little bit about how this has looked from like a market landscape. We really, again, started on the left with these like plugins, maybe AI power IDEs. We've now moved on to local agents. I think your median developer is kind of starting to adopt things like Claude Code. The next generation, where your early adopters are now, is really cloud agents that have their own sandboxes in the cloud. They might be driven through a web API, a GUI, something like that. You can get a lot more agents working in parallel that way. And then what we're really seeing with the top 1% of early adopters here, what we're calling agentic engineers, are folks who are orchestrating multiple agents that can work together and play off of each other. We call this agent orchestration. A little bit about what orchestration is useful for. It's not useful for every single task. You're not going to want to have multiple agents swarming on a bug fix or a new feature. But there are a lot of tasks in software engineering that are highly automatable and very repeatable. So things like code maintenance and tech debt really make up the bulk of this. So a lot of things like remediating open source vulnerabilities, automating your documentation or release notes, bringing apps up to date, so like migrating from an old version of Java to a new version of Java, moving from like one React state management system to another. A lot of like tech debt oriented things, like we've used it to add type annotations throughout our Python code base. These are all like toily tasks that developers don't want to do. They're a little bit too big for like just tell Claude Code to just migrate your entire app from Angular to React. It's going to fall down. But it is the sort of thing you can get a fleet of agents working on together. Again, this is not something we expect folks to use for every task, and it's not something we expect every engineer to use. What we're seeing is that every developer is using one agent locally to do one thing at a time. That's great. That's a very meaningful lift in productivity, something like 20 to 30% per developer for writing code. But what we're seeing is that some engineers are able to identify those big chunks of work, big chunks of toil that their teams are doing, and use agents for select repeatable tasks to get even better productivity gains, another order of magnitude of productivity gains for things like migrating code bases, automating CVE resolution, things like that. A little bit about what this workflow looks like when you do have multiple agents. For a single agent, it's fairly simple, right? It's very similar to the inner loop of development. You prompt the agent makes some changes. You check the output, make sure the code changes look good. You run the application, et cetera. And then maybe you prompt the agent again to drive it a little further, or you accept it and say this is good. When you've got multiple agents, it gets a little bit trickier. You need to start by decomposing the task into nicely separable pieces, and we'll talk a little bit about how to do that well. Then you can get an agent running on each of the pieces, and you're going to run an agent loop for each one of those. And then at the end, you'll have to collate the output together into a single pull request or get it all merged into your code base together. Importantly, there's still a human in the loop for each of these agent loops, right? You have to verify that each one has done its job correctly. So I like to tell folks that you shouldn't expect to, if you're orchestrating multiple agents on a big task, you shouldn't expect it to be 100% automated. It should be something like 90% automation and then 10% human in the loop, human checking the output. So there's still a lot of human work involved here. A bit about more tactically what this looks like in terms of working with Git. Typically, what we see folks do is start a branch. They'll add some kind of context to that branch about what is this project we're working on. Are we migrating Angular to React? Are we migrating from an old version of Java to a new one? Add that in the OpenHands world, we'll call it a micro agent. There's also agents.md. You might be familiar with cursor rules, things like that. But you can check a file into the repository explaining to the agents what's going on here. You might want to get some scaffolding in place. And then you can send off your agents. Each agent should create a pull request into that branch you've created, and that's where you're going to accumulate work over time. I would say something around 3 to 5 concurrent agents is where my brain starts to break. I've seen folks do dozens, especially for like very small repeatable tasks. But you can just kind of iteratively merge those PRs into that V1 refactor branch, and then once you're done, once all the agents are finished, you validated all their output, you can merge that into the main branch. A little bit about like how to properly decompose tasks. You're looking for tasks that can basically be one-shotted, right? Something you're reasonably confident, you can give it to an agent and the agent's going to complete the task. Maybe you need one more turn of the loop and you prompt it again, but you should be fairly confident the agent's going to be able to take this on. You also want it to be something that can fit into a single PR. And you want to have like a clear set of dependencies between the tasks. You want to know, okay, once I get A done, then I can do B, C, and D in parallel, and then I'm going to do E once those are all done. Having that parallelization is super helpful. It means that it's going to move a lot faster. If you're trying to do everything serially, it's going to take a long time, and you have to wait for agent A to finish before you start agent B. So the more you can parallelize, the better. Very similar to like managing a team of engineers. You might have one person working on front end, one person working on back end, something like that. And you also want something you can quickly verify or reject, right? You want to be, if you can know that like, hey, if CI/CD is passing, the thing did its job, I can trust it, it's okay, that's the best. Maybe it's something you need to click around to UI, make sure the app still works. But you want to be able to quickly, be able to look at the code, look at CI/CD and understand like, did it do the thing or did it not? You'll also want to think about how you're going to share context between these agents. Usually as you're working on a big task like this, you're going to learn things as you go. And you need to make sure that that information gets shared across all the different agents that are working here. There are a few different ways to do this. The most naive approach would be for a human to just like type into a chat window, to each agent, do XYZ, use version 1.2 instead of version 1.1. You can use like an agents.md or an OpenHands micro agent to share knowledge. The agents can even update that themselves automatically. Or you can even define tool calls that allow agents to pass messages to each other. All right, I want to show a bit of a demo of how this works. So I've built a script using the OpenHands SDK that's going to look at a GitHub repository, detect all the CVEs, all the open source vulnerabilities that are in that repository, and then send off a fleet of agents for each of the individual vulnerabilities to solve that vulnerability. I'm going to kick it off on the left side here because it'll take a minute. So I'm going to scan this Polaris repo, and I'll talk a little bit about how this is working as it runs. So essentially what we're going to do is we've set up one agent. You can see it scanning now. That's going to look at this repo and figure out how am I going to scan for vulnerabilities. It can look at what programming language is being used. It can see if is there a Docker file. Maybe I can build the image and scan that. This is the really nice thing about agents is that it doesn't have to have very explicit instructions on how am I going to scan for vulnerabilities. It can kind of figure its own thing out. And you can see the agent here is it's installing Trivy. We're going to see it run Trivy to gather a list of vulnerabilities. And then where the real power comes in is that once we get that list of vulnerabilities, for every single vulnerability, we can send off a new agent to solve that one. This is much better than, say, having a single agent trying to solve them all, because one, there might be just like a ton of, if there's 100 vulnerabilities, it might get lost. You've probably seen agents get lazy. It'll solve 3 and then say, OK, now go hire a team of people to do the rest. So it's really nice to separate it out. And this way, too, if we have 100 vulnerabilities, say, if I can get 90 of those merged and 10 of them get stuck, that's still a big win, right? We've still resolved 90% of the vulnerabilities here. So parallelizing this makes it go faster and means that we can get to partial successes really quickly. So each of these sub-agents is going to research the solvability of the vulnerability handed to it. It's going to update the relevant dependency, maybe fix any breaking API changes that are in the code, and then open up a pull request for us to merge. So you can see our scanner here has found 3 vulnerabilities, and we've kicked off 3 different agents. Each one is going to solve a different CVE. A bit about what this looks like in pseudocode. I'll make this bigger. This is using the OpenHands SDK to actually initialize the agents. You can see we give the agent a terminal that it can use. We give it a file editor so it can mess with the code base. And we give it a task tracker so it can plan and execute on that plan. And then we just send it a message saying, hey, scan this repo for CVEs, use Trivy, put your results in this JSON file. And then we can read up that JSON file, grab each vulnerability, and then inside of a for loop, just send off a new agent saying, solve the CVE ID. What's really nice about the OpenHands SDK is that we can run each of these agents inside of their own workspace, inside of their own developer workstation, so that each one gets a nice sandbox. They're not stepping on each other's toes, trying to edit the same code, things like that. So they each get their own, it's almost like they're individual developers working on their own laptop. And you can get these running not only where the script is running, but you can run them inside of Docker containers. Like this script can connect to a Docker container or it can connect to a Kubernetes pod. So these agents can really be running anywhere, either locally or in the cloud. I can show a little bit about what this looks like in the actual GitHub repo. Let's see. This here is kind of pseudocode, but you can see we've got prompts for the scanner explaining exactly how to, let's make this a little bigger, explaining exactly how to go about scanning a GitHub repo. We've got prompts for the solvers explaining, exactly here's how to solve a particular vulnerability. Here's how you should investigate. Here's the format of the pull request we want you to open up. So it's all, neatly patterned according to our style guide, the way that we work, the way that we want to solve these CVEs. And then we've got a bunch of Python code that basically just invokes the OpenHands SDK in order to drive this whole workflow. Let's see where the scanners are at. So you can see as each of them are working here, they're moving through the code base. Each one is installing new packages with npm, looking for the packages they're supposed to be solving inside of package.json. We can let this run for a minute or two. It looks like they're starting to finish up. We should see a pull request come out for each of these. But in the meantime, I'm happy to take questions from the audience. Zach?
Always right at the back, isn't it?
So is OpenHands doing anything uniquely to mitigate code conflicts? Because if you have like 12 PRs that are raised, then how are you managing that if there's changes that overlap same file?
Yeah, it's a great question. I would say one thing we've noticed is that agents are exceptionally good at fixing merge conflicts. I would say actually better than humans because they'll actually look at the intention behind the original changes and what their changes were and try to merge them. So it can become a pain to like do another turn of the loop if the first change gets merged and there's merge conflicts in this other PR. But we often will put into a script like this just kind of like watching the PR. If merge conflicts crop up or there's a CI/CD failure, you just send the agent another message saying, please fix the merge conflicts. It's a fairly easy thing to automate.
How does OpenHands work with local models, and what is the smallest model that OpenHands works well with?
Yeah, great question. So we do work well with local models. We're totally model agnostic. We released a model with Mistral called DevScroll, which was trained especially to work well with OpenHands. I would say that's the best small model that you can run locally. Qwen 3 also works very well if you can get it running locally. I believe Kimi 2 works very well. So yeah, we actually publish benchmarks for all the different models and how well they work with OpenHands. I think we released everything from a 3 billion to a 32 billion with DevScroll. The 3 billion, you can imagine is not amazing, but it works.
Pardon my lack of imagination. You said you're not working in an IDE anymore. You're more working in OpenHands. Could you describe a little bit about that process for building the agents? And this is really interesting to see, but I'm trying to get my head around. Okay, where did you start and go? I need a CVE fleet of agents. How did that come about? Yeah,
I would say my workflow mainly switched over to using our web app. So to build the CVE demo, for instance, I would just connect it to the repo and then tell it exactly what I wanted it to build, what I wanted it to do. So one thing I was working on ahead of this is use the OpenHands software agent SDK to plumb in the GitHub token as a secret. And so this is a very standard, familiar way of using an agent, right? If you've used Devin or if you've used Joule, something like that, right? You're chatting with an agent. We can see it working on the right side of the screen. You can see it has a terminal, and we've got a VS Code here. So this is kind of like my daily driver. I think where OpenHands really is different is when you start working with the SDK, which really allows you to start driving agents with code, right? So if you're starting to build these very repeatable workflows, you want to be able to solve CVEs throughout your entire company's code base in some kind of patterned manner, you can write Python code that drives a very particular workflow. It's going to open up PRs that match a very particular pattern. It's going to prioritize criticals over anything else, et cetera. You can start writing Python code that really drives these agents in a more deterministic way, right? It allows you to kind of combine the non-determinism of the agents with these more deterministic workflows that patch those non-deterministic loops together.
Yesterday we heard about Claude Flow. When would you recommend OpenHands over Claude Flow?
or are they really two different beasts that I'm not quite got my head wrapped around yet?
I'm not familiar with Cloudflow, actually. Anybody want to give me a quick?
It's an agent orchestration.
Agent orchestration, okay, yeah.
Code that does swarming. So maybe generally your thoughts on agent swarming solutions.
Yeah.
Could you repeat the question? Just for the...
So yeah, so Cloudflow is a way to run multiple Claude codes and swarming agents. I would say one, what you're going to want to do. I've seen a lot of people like run multiple Claude codes like in tmux with like different panels, right? That works reasonably well for a few agents at once, but because they're all running on the same workstation, potentially trying to install different versions of different things, they might step on each other's toes a bit. It's really nice to give each one separation. So getting like sandboxes, running in the cloud somewhere, in a Kubernetes cluster, or at least in Docker containers on your workstation, super helpful. And I would say, like in general, you can graduate to these fleets of agents when you have a task that's super repeatable, something where you're going to be doing this over and over and over again, and it doesn't make sense for you to be like typing in prompts to different chat windows, and instead you want to have some kind of deterministic code-based flow.
So I realize this is a little bit tangential, but obviously for a repeatable task, it might make sense to have many agents working on it in parallel. How do you think about this for like new feature development where maybe you need a spec, maybe it's not quite as deterministic? Are you using the SDK to orchestrate stuff like that? Are you using one chat window at a time? Like, what's the process that you go for?
For new feature development, I typically will open up a few chat windows. Right, I'll have one agent working on front end, one on back end, something like that, because it's not super repeatable. If you're going to be doing like something hyper repeatable, where it's like every new feature is going to be a new page in your React app and a new API endpoint, maybe you can start to build some like boilerplate code that will help you drive the same workflow over and over again. But I think this stuff really shines more for the tech debt, more the code maintenance type tasks. Good question. Other questions? In the meantime, we can see we got 3 new pull requests from our agents, each one opening, closing a different CVE. So nice to see it actually worked.